Hi everyone, thanks for joining today's session about sustainable API, how to measure, design, build, and run very sustainable APIs. Today we are on the API Days, Munich API Days 2025. Uh, I apologize at first for the Munich friends. I did not change my background screen. There are a lot of Paris images. I'm from Paris, so it's why you saw the image Paris images. But promise next time I will change the images to maybe Munich or other cities. So let's start. First of all, for me, we are going to to define quickly what is about Green API. It's your set of principle patterns and best practices that help us to uh, build, to design very energy efficient APIs, resource efficient APIs, so as well environmentally compatible APIs. During this session, I will go just through some key points, measurement, how important our measurement during our journey of Green API, how to design, how to find the best principle to design APIs, and when it's come to implementation, how to leverage clean coding principles and patterns to implement our APIs in a very energy efficient way, and the importance of observability, continuous improvement when it's come to sustainability journey, and it's not about one-shot achievement. It's about having mindset of improving continuously and observing what happening according to the actions that we are doing. So first of all, as I said just before, the first step of all the things that we are doing is measurement. We have to measure anything that we should do and that we have done in order to see if we are improving anything or not. First thing, what to measure the energy efficiency or the carbon efficiency of our API. The first thing is just to have to find a way to reduce the environmental impact of our API, of our softwares, of our information systems, and to have less energy consumption and less greenhouse gases emissions. And in order to have some kind of concrete environmental data retrieving for reports for our top management in order they can decide where to invest to reduce the carbon footprint. And sometimes we need to do some technical optimization in order to have less energy cost or less resources, CPU, RAM costs in our production environment. We can anticipate by having this kind of measurement to see where we have the bottlenecks and where we can improve our API or something in order to raise the awareness of our other developer colleagues. We can measure in order to show them that we are not just guessing that the API is not very energy efficient, that we have the proof with our measurement. So we can anticipate the question of how can you tell me that can you prove me that my API is not energy efficient? And the second thing is that for me, the main mindset is all the things that we are doing in terms of sustainability should be measurable. It must be measurable, not should, sorry. And we can leverage tools, open source tools like EcoCode or Credingo now renamed. And during execution, we can use Visual VM, EcoIndex, Lighthouse, or something, some tools combined that we are. Also, we can use tools like API green score in order to have always the data, the measurement to see if you are doing well or not. The thing is that measurement and monitoring software energy consumption and emissions to identify the area of improvement is very important. We can use impact framework or plugins or Kepler's and Prometheus Grafana when it's come to observability. It's very important to have to keep this mindset when you are working on sustainability, but other topics as well. For first measurement tools, just we are going to see three measurement tools: design time, build time, and runtime. The design time is the API Green Score is tools designed and built from the API Thinking, a French collective. Very interesting tool and quickly evolving, and you can have a look on it. At the end of the slides, you have the link to the GitHub repository. Don't hesitate. It's very interesting, helpful, and it measures the design principle, the greenness of the design principles that you are using on your API. The second one is when it's come to implementation, you have to design well, but you have to implement well as well. So Creatingo X EcoCode, it's a SonarCube plugin, fully integrated to SonarCube, which can give you some eco-conception inside of your code, of your implementation. It's very interesting. You can have many insight on it. And the third one is the most important for me, it's the measurement during the runtime. Kepler, open source from Red Hat, I think. And the most important things for to use Kepler for me is the energy, the carbon footprint estimation. After all, on which you can leverage to measure with other entities or other softwares or other department of your company, and you have more high-level results. But the drawback is that it's a Kubernetes-based tool. But don't worry, you have also Scaffold as well, which could help you to achieve your goal. So you have just three tools. It's not the only tools which exist on the market, but I'm comfortable with this tool, so it's why I'm using or talking about these tools. And when you have the necessary tooling to measure your energy efficiency, your carbon footprint emission, you would like to have the necessary things to improve your carbon footprint, your energy consumption. It's why at the beginning you have to find the best design principle to achieve this goal. The first design principle is the energy efficient design. I will not go through all the energy efficiency design principle, but just have some most important keys. The lazy loading. It's very important to not load all the data that you have to process to compute. You can just load the only data that you need to process now and to delay the other data lately. And the optimization for low latency too is very important to save resource consumption, because when you can have asynchronous processing, CDN or API endpoint design, it could be very helpful. And the second principle is the efficient data processing. As I told just before, when you don't need to call over the network to retrieve anytime a data which is not changing every time, you can cache it, or when you don't need to compute every time to have the same result, you can compute once a result to cache it locally and to reuse it. It's called memorization. It could be very helpful to save the bandwidth when you have to call on the network, or to save the CPU usage when you have to compute some numbers. And you have the best practices with in many other languages like Spring with Cacheable, or Next.js with UseMemo or something, or the Redis caches or something. It's very helpful, interesting. And for me, the very important pattern with the energy efficient data, the efficient data processing, is to support the delta update. When you have billions of data, instead of sending every time all those billions of data, when you change it, you can try to have some kind of efficient delta calculation in order to send to the servers just the data which are changed over the time. So, but you have to be aware that you must implement a very efficient delta calculation in order to not lose the resource efficiency on calculating the delta instead of sending all the data to the servers or something. So you have to be careful when you use a delta calculation or resource tracking. But it's very helpful, interesting to not send in all the data over network every time you have to retrieve or to have to process data and to send it back to the server or to the remote caller. When you can use batch processing, it's very helpful and important, because instead of having 10 network or 10 HTTP call sending a number or requesting a second numbers, you can have some kind of request taking some kind of 10 numbers in the request in the payload and processing the 10 numbers, responding with 10 response. You have one call instead of 10. So it's kind of batch processing, and it can save a lot of bandwidth, a lot of network call, and it's very important when you have some kind of thread commissioned to call over network. They will not do anything or go away until they have not the response from the HTTP or the network call. So it's very important to handle well the network call inside your process. And the third one is to optimize the network traffic. The idea just before was, if I don't have to if I don't have the necessary, I have to call to the network, I have to do the network call, but I have to keep in mind to send the lowest payload or data possible to the network. Otherwise, I will have some kind of bandwidth consumption, energy consumption over the network. Now it's come to optimize the network traffic. Pagination is very interesting technique, or some kind of how could I say, technique or pattern to not send all the response that I have on my hand to the requester, but to give to the caller a way to have the next or the remaining data if you don't have the response in the sended data. It's very important and interesting to keep in mind. I have to send the minimum possible, and if the caller or the requester need another data, he can ask me to send the next data. And data processing and data compression, sorry. In our day, we have a lot of frameworks or languages implement default data compression when it's come to call over the network, like ggip and JGIP in Spring or something. But when you have to deal with legacy systems, sometimes you don't have really in the other side the necessary system which can understand or decompress before doing. But if you are on this kind of context, don't hesitate to enable it and to use the compression by default. And when you have to send large data file over the network, compress it before sending the file over the network. So it's very important. And efficient protocols. The best practices in our day is to use the recent or the very recent and most efficient protocol like HTTP2 or TLS, HTTP2 and 3, WebSocket for real-time communication, data communication, something. It's very important to update every time your tools, your library or something. And resource minimization. In resource minimization principle, we have the rate limiting, database optimization, and to reduce the network resources request to the lowest. It could be very interesting and helpful because when you have an API coupled with a database which is not very efficient, or your network call will be impacted, or your API performance will be impacted by the performance of the database. So it's very important to have a database really optimized in terms of queries or in terms of engine or something. So you can have techniques like indexing, database denormalization and caching, which is very helpful. And efficient data fetching or cache usage batch requests are some best practices that could help to achieve the reduce of the network resource request to the lowest. It can be very interesting. And when we are fully documented, yeah, we have fully implemented our best design principles, and we have the necessary tooling to monitor our energy consumption, our carbon footprint emission. It's come to implement well, not just to implement our design, because you have to implement it by keeping in mind that we have to be energy efficient, and we have to be to implement the eco-consumption patterns and principles. It's why green coding could really help to achieve this implementation. And when it's come to green coding, we'll not go through all the green coding principle, but I have just three in mind. The first principle is the code efficiency. For the code efficiency, we have three patterns that we talk about here. It's the avoiding the loops and repetitive operation is very, very interesting to save CPU and CPU and RAM usage. And you can use as well stream API operations or stream operations instead of having loops. Efficient data structure or data structure optimization could be very helpful. And the second pattern is object pooling. Instead of always creating and destroying object, you can have some kind of object pool or pool of object on which you can leverage, because creating and destroying is very energy consuming and very is very cost effective. Not very cost effective. Sorry. And the code duplication, it's the main pattern that we have to handle. Is if you want to be very efficient in terms of codes, it's not very easy to handle in if you have billions of line of codes, but you have tools to help you track the duplications and to factorize your code or something. So don't hesitate to use the tool that could help you to analyze the code duplication or something. And now we assume that we implemented with the green coding principles and so on. We have to host it in a very efficient way in order to be more energy efficient in our hosting as well when we run it. And will not go through once we will not go through all the green ops pattern or principles, but we'll just have some principle, the power efficient hosting, and the patterns start or expose your apps or API on demand. For instance, if you don't need your instance, your app, your API or something from 6 p.m. to 10 a.m. in the morning, you can switch it off and restart it in the morning. So you can save resources, money, and energy. It's very interesting. You can leverage daily clean or slim fast, which is very, very, very more efficient, but with some constraint. to achieve this kind of goal. You have to monitor your real resources need on production in order to set your infra just with the only needed resources, not over or underestimate your resources. And in our day, we have some kind of patterns, auto scaling. Implementing HPI is very, very helpful in order to have the lowest resources possible and to keep your API or software working well and scaling if needed and scaling down if there is no need to these resources. And we have always to real-timely monitor our metric in production to right-size our containers or something. And now, observability and continuous improvement. As I said at the start of this session, it's not just about having one-shot action and it's done, it's okay, and now I'm done. It's about keeping up of measuring and improving and measuring again and improving in order to see if our implementation is our implementation, our APIs is working well, consuming less, impacting less, or something. And now we need observability and continuous improvement to have to measure and reduce our carbon emission, to generate metrics for our top management in order to give them the insight, necessary insight to invest where it's matter, to collect data, to analyze the result, and to identify future next opportunities, and to anticipate the regulatories obligations or something. And observability have lot of interesting things, interesting applications or something. And now, as I said, for me, the key takeaway, if you have to go back on with one idea, is here. Every step toward efficiency count. Don't think that your step is too small to be started, or you are alone or something. So start. Don't be afraid. Every step count. Measurement and continuous improvement is the key for success. We have to measure and to improve regularly, continuously. Without measurement, we cannot do anything. And adopting Green API, Green software principles, pattern, and practices is our ally. It's not the only one, but it's our ally. We have to use them. But if we have other things more relevant, more important, more interesting, we can use it. You can use it. And leveraging the open source communities for tools, for best practices, for everything we are doing, open source is very relevant to tell us if we are doing right, doing wrong, what we can improve or something, how we can measure what is relevant nowadays. So don't hesitate. And when it's now at the end, I have just some resource and tools sharing. The first link is from API Green Score, from the API Thinking Collective. The second one is the Daily Clean from AXA France GitHub. We are using it in our company. SlimFast is also from AXA France. The GitHub is open source. You can contribute if you want. The Impact Framework is a plugin set of plugins from the Green Software Foundation, is open GitHub and open source. So don't hesitate to join the Green Software Foundation and the API Thinking Collective to contribute. And the last one is Kepler from Red Hat. I think it's open source as well. You can contribute and don't hesitate. So thank you for the session. I hope that it was shorter and understandable. Thank you.